Hi there, this is lesson 9.7, solving linear and nonlinear systems of equations. So our objectives are we're going to solve systems of linear and nonlinear equations algebraically and graphically. We are going to solve systems of linear and nonlinear inequalities graphically. So just like systems of linear equations, which mean we had two linear equations, those we wanted to find where the graphs intersect. Well, here we're going to do the same thing. We don't have any vocabulary. That's new, at least. So when we're solving a system with one linear equation and one nonlinear equation, here are our possibilities. These are just some examples, but we could have zero solutions where they never cross. We could have one solution where they cross at one point, or they could cross at 2 points and have two solutions. So these are the possibilities. So on the test, if I ask you, how many possibilities can you have when you solve a system with one linear and one nonlinear? So you can have 0, 1, or 2 solutions, and these are some examples. And you can draw anything that's linear, any linear equation, and any nonlinear. So let's look at the example 1. It says solve this system. So just like linear equations, we can use substitution, elimination, or graphing. So here we cannot use elimination because I have x squared, an x, and a y, and y squared. So what I'm going to do is, I'm going to take my linear equation 10y plus 6x equals 6, and I'm going to solve for x. Well, I'm not going to show the work here, but if you do it algebraically, you should know how. It's y equals negative 0.6x plus 0.06. And our other equation was 9x squared plus 25y squared equals 225. So on the test, you would show your work and you would actually do this. And then rewrite it and put your little bracket or brace so you know that this is your new equation. So now I'm going to use substitution. I'm going to put that in there. So I'm going to get 9x squared plus 25 times negative 0.6x plus 0.06 squared equals 225. Now here we can't forget basic math and order of operations. So because these aren't like terms, you can't combine them, and because you have more than one term, you can't use the power rule of exponents. So basically what you have to do is you have to take this whole binomial and times itself and FOIL it. Then you distribute the 25 before you combine with the 9x squared. So I'm not going to show all the math. You can look in the book. They've got all the steps if you forget how to do basic algebra. So basically we end up with 18x squared minus 18x minus 216 equals 0. So it's a quadratic. So we're going to set it equal to 0. We're going to factor. Well, you can divide the entire equation by 18. We end up with x squared minus x minus 12 equals 0. Now I can factor that and get x minus 4 and x plus 3. When we solve, we get x equal 4 and x equal negative 3. So we have two solutions, two x solutions. So therefore, we have to put this back into one of the equations. Does it matter? No. When you put 4 in, if I take this equation and I put 4 into there, I'm going to get y equals negative 1.8. When I put negative 3 into this equation, I get y equals 2.4. So my solutions are 4 comma negative 1.8. Remember, the solution's a xy coordinate, and negative 3 comma 2.4. So make sure you put the right x with the right y, and because you have two y solutions, I'm going to have two x solutions to go with it. So I put it in either one, it doesn't matter, and check it. Okay, so here it's just about the process because you already know how to solve equations, you already know how to solve systems, and basically you're going to use substitution or elimination. And you've already graphed all these equations. We graph nonlinear, and linear. Okay, it's not just conics, it could be anything, like an absolute value, a cubic, a cube root, a square root. So these are all equations and functions that we've already have graphed. So you can't forget basic math. So pause this, do the guided practice 1A and 1B, and we'll move on to example 2. Okay, so example 2 tells us, so it's guided practice. So if we are going to have a quadratic system containing two conics, okay, so we have two conics, these are all conics. We may have anywhere from 0 to 4 solutions. And these are just some examples. So this case, I have a parabola and a hyperbola, and I got 0 solutions. I have a circle and a parabola, I got 1 solution. I got an ellipse and a parabola, I got 2. I have a circle and a parabola, and I got 3. I've got an ellipse and a circle, and I got 4. So these are when you have a quadratic system, which means the highest power is 2, degree is 2, and they're all both conics. These are your possibilities. Another possible good test question. And I might ask you to give me examples of each one, draw me examples, and you can just find any two. All right. So example 2, solve the system. We've got two quadratics, and it looks like we have a hyperbola and a circle. So the first thing we need to do is we have to know how to graph these. If they're quadratics and they're conics, we've got to know how to graph them. So let's go and graph these equations. So x squared plus y squared equals 45. And I'm going to rearrange this to say negative x squared plus y squared equals 27. All right, so actually we don't need to graph this. We can look at this and go, how can we solve this? Can we use substitution? Well, I wouldn't want to do substitution because you have squares for both these variables, and you're going to have two equations that you have to substitute twice. But I can use elimination, right? These are exactly the same, and they happen to be opposite. So this cancels a 0. This becomes 2y squared equals 72. Y squared equals 36. And remember, when you take the square root of an equation and you're solving for a variable, you get two solutions. We have two y solutions, plus and minus 6. So now we have to plug this in to find y. So if I plug it into x squared plus 36 equal 45, I get x squared equal 9, or x equal plus or minus 3. So now I take 6, comma 3, 6, comma negative 3. Oops, I got it backwards. Start with the x. 3, positive 3, comma 6, positive 3, comma negative 6. Then I have negative 3, comma positive 6, negative 3, comma negative 6. So I have 4 different solutions. Make sure you get them right. Don't do what I was about to do, and because I saw for y first, I just assumed while paying attention that that was my x coordinate. So remember, coordinates are written in order, x, y. All right, pause this and do the practice problems. So now we're back to example 3, and I don't know what's going on here. All right, so example 3 is solving quadratic inequalities. All right, so just like linear inequalities, we have to graph them. We can't use algebra for these. So here we've got, if you change that to an equation, it looks like we have a circle and we have a hyperbola. So you've got to know how to graph these. So our first one, I'll take our equation. This one we do. When we have inequalities, we do have to know how to graph them. If you don't, that's going to be a problem. 16. So here's our system. So let's graph our first one. It's a circle. Okay, so my origin is, my center is 0, 0. My radius is 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so I've got all these points, and I'm going to make a circle. It's the best circle I've done so far. All right, so now, because it says is less than, so I need to pick a point inside and outside. I'm going to pick inside because I can pick the origin. So if I put 0, 0, does 0 less than or equal to 49 true or false? It's true, so my solution I'm going to do in a really light yellow is everything inside the circle. Okay, just like in inequality, we test a point and find where here we find where the solution is. So with a circle, that's easy. It's either inside or outside. So wherever you get a true solution, that is where your solution is for the inequality. So next, I have a hyperbola. Well, hyperbola is equal to 1. So I'm going to take this and I'm going to use algebra. I'm going to divide by 16, divide by 16, divide by 16. So I get x squared over 16 minus y squared over 4 greater than 1. So you got to know your fractions. You got to know, this is what you got to know. Do I divide by 4 or do I divide by 16? Well, if you divide by 4, you'd have a denominator and a number that's not 1 over here. So that's not going to work. So you're either going to have 1 over here and possibly denominators, or you're going to have denominators and equal to 1. So my center is 0, 0. Okay, because the subtrahend hand is y and the minuend is x, I know it's going to be horizontal. Okay, so here is a square, so a is 4 and b is 2. So a is going to go horizontally 1, 2, 3, 4 units. That's going to be my vertex, correct? And then I'm going to go 1, 2, 3, 4 units here. That's the vertex of my hyperbola. And then my co-vertex is going to be 2 units and 2 units, right? So I make this little rectangle. And I know it's going to go, my isotopes are going to do this. All right, now I need to draw my parabola. It's going to do from the vertex, right? Not the foci. The foci is going to be inside the U, so my vertex oops, let's drew this wrong. So the solution is where they overlap, and they overlap here, here. How do I know that? Whoops, I skipped a step, didn't I? Well, I just happen to know it and I can see it. However, you're going to pick a point the solutions are both going to be inside the parabolas or they're going to be outside the parabolas. So I'm going to check this origin 0, 0. So if I put 0 in here, I'm going to get into this second one. So I'm going to get 0 is 0 greater than 16. Whoops. I got that totally wrong. So is 0 greater than 16? Which example is this? All right, so, whoopsie. So this is my hyperbola. So I put 0 in here. I get 0, so that's false. So actually, I have this wrong. My solution is going to be all of this blue part, but contained to inside the circle because it's where they overlap. So they overlap on all this blue part, everything but that little piece right there. So that is your solution. Okay? It's that simple. Inequalities. So now we've got one more. So stop it, do the guided practice. We have one more example. And it's going to be quadratics and absolute value, example 4. So we're going to have y greater than or equal to the absolute value of 2x minus 4 and y less than or equal to negative x squared plus 4x plus 2. Well, I've got an absolute value and I've got a quadratic. So I'm going to first start with the absolute value. So remember, I need to change this to say 2 times x minus 2 because it needs to be in factored form, not distributive form. So my vertex is 2, 0, hk. So 1, 2, 0. And if I want to find the y-intercept, I put 0. So it's going to be at 4. 1, 2, 3, 4. And it's a solid line. I'm going to pick the origin, 0, 0. So 0 is negative 2 times 2 is negative 2. The absolute value is negative 2. Is negative 2 less than or equal to 0? Is it? It is. Oh, actually, I put 0 in here, so we get, oh, I have to put in the original equation. Sorry. So 0, so it's negative 4. So is 4 less than or equal to 0? That's false. So my solution for this is going to be here. Okay? I also can go to the y-intercept, and when is y bigger increase inside here. All right, so now I have a quadratic. How do I solve a quadratic? Well, I have to find what a is. So a is negative 1. I know it's going to open down since x is squared. And I'm going to find the axis of symmetry, which is negative b over 2a, which gives me 2. So x equal 2 is my axis of symmetry. My vertex, I put 2 back in here to find y, and I get comma 6. So 2, 6 is my vertex. I know it's going to open down. Where is my 0? At positive 2. And then I can go over here 2 units, which is about right here. So the graph is going to do this. I know a is negative, so it's going to open down. And it says y is less than. So when does y get smaller? In here, which is here. And where's my solution? My solution is at the overlap, which is just right here. Inside this little section right here is my solution. All right, pause this video and do the rest of the guided practice.